According to the provided National Electrical Code sections, it appears that the installation may not require an additional ground rod at the trailer. NEC Section 250.32 exception allows the use of an equipment grounding conductor that is part of a Type SE cable or other multi-conductor cable as a grounding electrode conductor under certain conditions. In this case, the feeder cable includes a bare number 2 conductor that is used as the grounding conductor, which meets this requirement. NEC Section 550.16 addresses grounding requirements for mobile and manufactured homes. It specifies that the grounded conductor, neutral, must be insulated and that an equipment grounding conductor must be installed. However, it does not explicitly require an additional ground rod at the mobile home. NEC Section 550.16b states that the electrical system of a manufactured home must be grounded in accordance with the provisions of Article 250. It does not provide additional requirements for grounding at the mobile home. Based on these NEC sections, it is reasonable to conclude that the installation described does not violate the NEC and that it is optional to install an additional ground rod at the trailer. The concern about creating a ground loop and an alternate path with different impedance is valid. However, in this case, the grounding conductor is part of the feeder cable and is sized appropriately for the circuit. This helps minimize the potential for ground loops and ensures that current will flow primarily through the intended path. Therefore, it is likely that the installation is code compliant and that an additional ground rod is not required. However, it is always recommended to consult with the local inspector for their specific interpretation and approval. To expand on this, let's delve deeper into the nuances of grounding and bonding, especially in the context of mobile homes, manufactured homes, and similar structures. Grounding and bonding are critical for electrical safety, ensuring that fault currents have a low impedance path back to the source, allowing overcurrent protective devices like circuit breakers or fuses to operate and clear the fault. The National Electrical Code, or NEC, provides comprehensive guidelines on how to achieve this safely and effectively. Firstly, let's clarify the difference between grounding and bonding. Grounding refers to connecting the electrical system to the earth, typically through a grounding electrode system, such as ground rods, ground plates, or metal underground water pipes. The purpose of grounding is to stabilize the voltage to earth during normal operation and to provide a path for fault current to flow back to the source in the event of a ground fault. Bonding, on the other hand, refers to connecting all non-current carrying metal parts of the electrical system together to create an electrically conductive path. This includes metal conduits, metal enclosures, metal equipment frames, and so on. The purpose of bonding is to ensure that all these metal parts are at the same potential so that if a fault occurs, there is no voltage difference between them, which could pose a shock hazard. Now, let's consider the specific requirements for grounding and bonding in mobile homes and manufactured homes, as outlined in Article 550 of the NEC. As previously mentioned, Section 550.16 addresses the grounding requirements for these types of structures. It mandates that the grounded conductor, which is the neutral, must be insulated. This is to prevent unintentional grounding of the neutral conductor, which could create a parallel path for neutral current and potentially lead to objectionable current flow on the grounding conductors. Section 550.16 also requires the installation of an equipment grounding conductor. This conductor is typically a bare or green insulated wire that runs alongside the circuit conductors and is connected to the grounding terminals of receptacles, equipment enclosures, and other metal parts. The equipment grounding conductor provides a low impedance path for fault current to flow back to the source, allowing overcurrent protective devices to operate and clear the fault. The exception in Section 250.32 allows the use of the equipment grounding conductor within a multi-conductor cable, such as a Type SE cable, as the grounding electrode conductor under certain conditions. This means that the equipment grounding conductor can be used to connect the electrical system to the grounding electrode system, such as a ground rod, at the service equipment. However, it's important to note that this exception is subject to certain limitations and requirements. For example, the equipment grounding conductor must be sized appropriately for the circuit, and it must be installed in accordance with the requirements of Article 250 of the NEC. Now, let's address the concern about ground loops. A ground loop occurs when there are multiple paths for ground current to flow, creating a loop. This can happen when there are multiple grounding electrodes connected to the same electrical system. Ground loops can cause objectionable current flow on the grounding conductors, which can lead to nuisance tripping of circuit breakers, overheating of equipment, and even electrical noise that can interfere with sensitive electronic equipment. In the situation described, the concern is that installing an additional ground rod at the trailer could create a ground loop, since there is already a grounding conductor running from the service equipment to the trailer. However, in this case, the grounding conductor is part of the feeder cable and is sized appropriately for the circuit. This helps minimize the potential for ground loops, since the grounding conductor provides a low impedance path for fault current to flow back to the source. In general, it is not recommended to install multiple grounding electrodes at different locations on the same electrical system, as this can increase the risk of ground loops. However, there are certain situations where multiple grounding electrodes may be required or permitted by the NEC. For example, Section 250.53A3 requires that all grounding electrodes that are present at a building or structure must be bonded together to form a grounding electrode system. This is to ensure that all parts of the electrical system are at the same potential, which reduces the risk of electrical shock. In summary, the decision of whether or not to install an additional ground rod at the trailer depends on a number of factors, including the specific requirements of the NEC, the local electrical codes, and the advice of the local electrical inspector. In many cases, it may not be necessary to install an additional ground rod, as long as the grounding conductor is sized appropriately and installed in accordance with the NEC. However, it's always a good idea to consult with a qualified electrician or electrical inspector to ensure that the installation is safe and code compliant. To further clarify the requirements and considerations for grounding and bonding in this scenario, let's consider some additional aspects. Firstly, it's crucial to understand the role of the service equipment in the overall grounding system. The service equipment is the point where the electrical service enters the building or structure. It typically includes the main disconnect, the overcurrent protective devices, and the grounding electrode system. The grounding electrode system is the means by which the electrical system is connected to the earth. As mentioned earlier, this can include ground rods, ground plates, or metal underground water pipes. The purpose of the grounding electrode system is to stabilize the voltage to earth during normal operation and to provide a path for fault current to flow back to the source in the event of a ground fault. The NEC requires that the grounding electrode system be installed in accordance with the requirements of Article 250. This article provides detailed guidelines on the types of grounding electrodes that are permitted, the size and installation requirements for grounding electrode conductors, and the bonding requirements for various metal parts of the electrical system. In the case of a trailer or manufactured home, the service equipment is typically located at the point where the feeder cable connects to the trailer. This may be a disconnect switch or a panel board. The grounding electrode system for the trailer should be connected to the grounding busbar in the service equipment. The grounding busbar is a metal bar that is used to connect all of the grounding conductors together. It is typically located in the service equipment enclosure. From the grounding busbar, a grounding electrode conductor is run to the grounding electrode system. This conductor must be sized appropriately for the size of the feeder conductors. The NEC provides tables that specify the minimum size of the grounding electrode conductor based on the size of the ungrounded conductors. In addition to the grounding electrode system, it is also important to bond all of the non-current carrying metal parts of the electrical system together. This includes metal conduits, metal enclosures, metal equipment frames, and so on. The purpose of bonding is to ensure that all of these metal parts are at the same potential, so that if a fault occurs, there is no voltage difference between them which could pose a shock hazard. The NEC requires that bonding be performed in accordance with the requirements of Article 250. This article provides detailed guidelines on the types of bonding conductors that are permitted, the size and installation requirements for bonding conductors, and the bonding methods that must be used. In the case of a trailer or manufactured home, it is important to bond the metal frame of the trailer to the grounding system. This can be done by connecting a bonding jumper from the grounding busbar in the service equipment to the metal frame of the trailer. The bonding jumper must be sized appropriately for the size of the feeder conductors. It is also important to bond any metal water pipes or gas pipes that enter the trailer to the grounding system. This can be done by connecting a bonding jumper from the grounding busbar in the service equipment to the metal water pipe or gas pipe. The bonding jumper must be sized appropriately for the size of the water pipe or gas pipe. Now let's address the issue of ground loops again. As mentioned earlier, a ground loop occurs when there are multiple paths for ground current to flow, creating a loop. This can happen when there are multiple grounding electrodes connected to the same electrical system. In the case of a trailer or manufactured home, a ground loop could occur if there is a grounding electrode at the service equipment and another grounding electrode at the trailer. To avoid ground loops, it is generally recommended to have only one grounding electrode system for the entire electrical system. This means that the grounding electrode system should be located at the service equipment, and there should not be any additional grounding electrodes at the trailer. However, there are certain situations where additional grounding electrodes may be required or permitted by the NEC. For example, if the trailer is located in an area with poor soil conductivity, it may be necessary to install additional grounding electrodes to ensure that the grounding system is effective. In such cases, it is important to bond all of the grounding electrodes together to minimize the risk of ground loops. This can be done by connecting a bonding conductor from each grounding electrode to the grounding busbar in the service equipment. The bonding conductor must be sized appropriately for the size of the grounding electrode conductors. In conclusion, the grounding and bonding requirements for trailers and manufactured homes can be complex and depend on a number of factors. It is important to consult with a qualified electrician or electrical inspector to ensure that the installation is safe and code compliant. It is always recommended to adhere to the guidelines of the National Electrical Code, NEC, and local regulations for safe and effective grounding and bonding. This will ensure the safety of the electrical system and minimize the risk of electrical shock and fire hazards. Remember to consult with local authorities having jurisdiction, such as the local electrical inspector, for final approval.